Welcome to another episode of the dOrg Hot Seat, and this is a special one because we've got a dOrg member attending this dOrg Hot Seat, but as a project member. Manak, how are you? Good to have you, man.
I'm great. I'm great. Thank you for inviting me as a project, not as a member this time. So yeah, excited to be here and speak about Epoch. And I have a woman here with me. He's my co-founder, and tonight my partner for this sesh- session we're gonna have. Yeah.
Amazing. All right, this is the dOrg Hot Seat, so let's get this party started. We've got a coordination layer, we've got solvers, we've got chain abstraction, we've got intents. Like in the first 20 words that we see on your website, there's pretty much every buzzword except AI that we could have thought. To the English language, please.
Uh, we don't have the word AI in there because we know that we don't need that right now. The others they belong there. That's why we have put them there. It's not just fluff. So yeah, in simple terms, we are building an intent solver coordination layer, which I first have to explain to you what intents are. So intents is this new paradigm of interacting with Web3 applications, with crypto, with blockchain, where as a user you don't have to like go to a smart contract protocol and give them specific steps on okay. I want to put in this token, this amount, this would be the slippage. All of these actions are just hidden away from the user. All he needs to do is tell his intent or like the outcome, and there are these sophisticated like players in the background uh, that figure out how the user should reach there. So, from the user's point of view, uh, 4, 5, 10 steps that include like bridging, swapping, deposits, all of these are just abstracted away. So yes, it is. It sounds complicated because we are building an infra for the dApps to use or the protocols to use. But from the end user point of view, it's as simple as they going to a dApp, doing one signature, and just executing whatever they want.
Nice. We're gonna go to the intents a little bit later because I'm super interested on how technically the intents work in the background. The idea is quite simple, right? Like you just say like my intention is to swap that match at a particular price, and then that's it. Then the magic happens and is picked up by whoever it was. But I'm interested on the chain abstraction as well. Can you do intents cross chain?
Yes.
And but so I guess that the answer was yes, but let's go a little bit deeper. Like, how can you do chain abstraction on if what you want is like, are intents always chain agnostic, or like do you like are intents, some of the intents can be chain agnostic or some are chain specific? What if the intent is bridging into a particular chain? Like how do intents and cross chain interaction work?
That's actually a great question. So, if you look into like the intents history in Web3, so the second use case that came out of intents was actually bridging. So, and the first one was swapping. So, yes, what you said, they can be chain agnostic, they can be chain specific, but what we are building is intents that go one step further, where it's not just like you are interacting with a specific chain to do swaps or like to do bridges. You can do much more with those intents. They're completely composable. You can bring DeFi apps into intents, make new DeFi protocols, and all those sort of things. So yeah.
Okay, gotcha. I think the last part is the solvers. Are you guys a protocol for solvers, or are you solvers yourselves?
So we are not solvers, like we're not solvers ourselves, but we're making this whole network for other solvers to join in. But also we know that like a lot of the industry protocols and a lot of the industry is moving towards solvers. So we would need like a part, like a a protocol or like a infrastructure that can coordinate all of these solvers that are like different protocols are going to come up with. So that's our main focus. That like we can like go to these other networks, solver networks. These are the solvers that are very good at what they do. Let's say CrossSwap, they run a solver network for DEXs. Across runs a solver network for bridging. We know they're like great at it. They've optimized their own processes very highly. So we're going to coordinate them together. That's basically our own like infrastructure, and also like there's no solver for like other use cases than bridging and swaps right now in the space. If there are, they're mostly like very early alpha, that sort of thing. So we are making this whole framework for others to run solvers that are for like those specific use cases. Let's say somebody wants to create a solver for restaking, for Bitcoin roll-ups and things like that. But there's no framework out there. There's no existing protocol, so they can use us to start those solvers. Our aim is to make running solvers as easy as now it is to run roll-ups. Just one click, pick a few modules, and like optimize your logic, maybe bring in your liquidity, your inventory, and then just run a solver.
One of my understandings was that solvers are very hard um, to produce at scale or to decentralize from a protocol perspective, because actually solvers are competing against each other. So you actually don't want your solving software to be the same as another one. You want to have that edge over another solver. Am I missing something?
Yeah. Abhimanyu is speaking something.
Am I not audible? Just
You are audible, yes.
I'm
Yeah.
audible? Okay. So yeah, that's the thing. Like solver market needs to be competitive, so everyone keeps improving. And if you just have one solver that's solving literally everything, they'll start finding you not so good trades or not so good solutions. And then it becomes sort of like a monopoly where you get whatever you're getting and there are no improvements. So the idea behind this competitive market is if you align the incentives right, where all the solvers have all the right incentives to keep improving themselves and also not drop out of the network if they are not providing the best solution. And I believe it produces like a competitive market where each solver is trying to give out the best solutions, but even if they are not giving like the best solution, they have incentives to be part of network and not drop out of it. And that also prevents like creating a monopoly of just one solver who is just giving you good rates initially, but then like substandard rates after that point.
Wow, that's amazing. That's a really good point. Uh, the Do you provide these incentives? Is Epoch providing extra incentives to solvers even if they don't win in the protocol that they are competing on? They still have something from Epoch. Is that how you keep them in?
Yes, exactly. Like there's a baseline decided saying, okay, anyone who provides a solution better than this baseline solution will get some incentives. And as you go up the curve in terms of providing the better solution, you get more rewards. But you do get rewards as long as you're providing a better solution than a baseline. And a similar approach is also followed by CowSwap. Not exactly the same, but kind of similar. So that's sort of like becoming a usual approach in the solver market. Like solvers should be there and they should not drop out of the network.
Right. So historically, what I'm understanding here is that there was this solver market, but if one solver had just superior technology or superior math, superior algorithms, or even like sometimes could have been just like huge amounts of liquidity that others, so it could like they could economically push the other ones out of the market. Then there was like it effectively turned into a monopoly instead of competition. So a new model, a new paradigm comes with CowSwap and Epoch that allows protocols that need solvers to provide these gradual scale rewards to solvers so they maintain a competitive market.
Yes, exactly. Like for Epoch, it would be like the incentive would be Epoch tokens. And for CallSwap, I think it's they have their own, I don't remember now if they're giving some token or some fees out of what user is paying, but that's how everyone is trying to keep all the solvers inside the network right now. Like not everyone, but CallSwap and us.
That's amazing. Okay, got it. I think the value of Epoch Protocol is pretty clear right now. Let's go. So, as you know, dOrg is a pretty technical DAO. So, I'm going to ask a question that I'm really uh, like intrigued on, and it's like, what happens with intents? What is an intent at a granular level? Is it a JSON with like a particular how can I create arbitrary intents and they will be picked up by whom? Like what's the format, or how do I add new intents? How do I like, what's the unit of an intent?
Yeah, okay. For intent, everyone is trying to come up with different solutions to this. If you look at, let's say, something like Essential, they are coming up with their own language. If you look at Epoch Protocol, it's more or less like a structured JSON object where you say, hey, this is the token that I want, and this is the chain that I want it to be on, and this is what I'm willing to give for. And you can also specify certain optimization factors. And once you do so, it's totally up to solvers to decipher and do what needs to be done. But for us, it's like lowest entry value that is like a structured JSON object that's it. But also, a lot of other players are trying to create their own language, their own uh, framework or methods of giving out intents.
And basically, what the user is doing is approving the use of that token. Then the solver just says like, "Hey, I know how to do it," and then during this,
Yeah.
just with pre signature.
And you can have like you can basically like make this intent in any format you want. It's just that the solvers need to also know this format and should accept to solve in that format. So basically like there's one solver framework that has been coming out, which is like the most famous one, and the most solvers are willing to accept it, which is like ERC 7683 from across and Uniswap. And yeah, so like that's the most famous standard right now. If you look into it, it's also just an object of a token in, token out, and like a couple of like other like there's also like generic bytes in field in it, which is called data. That's where the magic happens for like all the other sort of intents. Let's say maybe bridging or maybe some generalized message passing, whatever. And like anyone can put in like any sort of like application specific logic in that data bytes field. And yeah, the solvers can pick it up and decide to solve it.
Yeah, so I actually had a question regarding this. Maybe this could be a great comparison for what Lansky was asking. So let's say I'm running a solver on CowSwap right now. Okay.
Yeah.
So what do I have to do in order to run it on Epoch? That might be a great comparison.
So, so it depends on like what are the specification for CallSwap solvers. They have different versions of like a Uniswap X solver would have a different version, a CallSwap solver would have a different specification. What we're working on right now is firstly if we can enable those solvers to work out of the box for us. That's like the best case scenario. And for solvers that support RFQ for let's say Uniswap X, we have a framework or like Epoch Protocol can directly support those. But solvers that cannot like directly work with us, we have two different approaches. One is like putting in an adapter between the solver and Epoch Protocol. And the second approach is asking the solver to run a customized version of the API endpoint that they are like running. So they can use use their own logic for figuring out if a trade makes sense for them or not, or if the incentives are right or not. But the way they respond to epoch queries and then settle the intent, that is just the cheap modified version of what they were originally done. So we talked to a few solvers and they were like, yes, give us a something that we can run, and we are happy to host it and answer to like RFQs of Epoch Protocol and settle the orders. So I think like the best case scenario is we simply uh, they plug right into us. The second best case scenario is like using adapter and the solvers do not need to change anything. And lastly, we can ask them to like run a custom piece of software that they can just run and then be done with it.
Okay. Yeah. Thanks a lot.
And where does the integration happens? Does it happen at the dApp level? Like me as a dApp provider, I would ask the user, or I would provide like the UI for submitting these intents into Epoch Network. So you basically want to integrate with as many dApps as you can.
Yes. That's part of like how we want to roll out. We get integrated with dApps that have like very specific requirement of token to be using them. Sort of like if you go to any restaking platform, you either need to have Ethereum or restake ETH on most like on Ethereum mainnet. So they can have like a button saying, hey, onboard my user with just one click. So the dApp would decide what the intent for the user should be. User just tells the dApp which token they are willing to give on which network. And that creates sort of like a structured object that is sent to Epoch Protocol, and solvers find a way to get user from the initial token and chain they were on to their desired end state. That's one approach. Second thing is like being integrated with wallets. So wallets can like leverage Epoch Protocol to be part of, like they don't have to go and make direct integrations with different DeFi protocols. All they need to do is like create a custom UI for, let's say, using Aave or using any other restaking or staking platform or anything like that. So the wallet experience also improves significantly. Like users can truly feel like chain abstracted executions. And for dApps, it's sort of like just one click onboarding to be using those dApps.
Gotcha. Perfect. Thank you. I always like to end these questions or these interviews with a question that's slightly less technical and maybe a little bit more philosophical. And I think we went on to blockchains because we went on to like this decentralization, code is law. The smart contracts will take care of everything and it'll be completely transparent what they do, and sort of like we're seeing that we're kind of going back to the centralized players, the solvers. It's also happening with proof of stake, for example, with proposer builder separation. The builders of the blocks are centralized entities, very specific. What happened that we are needing to go back to off-chain kind of centralized actors again to take care of the critical paths that of the technologies that we're using?
That's like a confusing question. And answer to it
I
is like,
actually love the question as well.
Yes.
That was exactly what I also used to think that, with all of these option actors, everything is happening in a black box and you don't know like what the code is. There's no transparency anymore. So yeah, I actually love it. And I had the exact same questions a couple of months ago.
but also the answer to it is very simple. When you look at it, like running all these executions on instead, like all the state transitions.
Now it's you who just broke up a little bit. Maybe you can repeat that, I remind you.
So when you look at blockchains, the nodes need to like make all the state transitions, and it's very expensive. Like the consensus among them, and literally everything is very expensive. So the idea behind making everything off chain is as long as you can verify things on the chain, like as long as you can verify the execution of the transition that you asked for on the chain, you can make all the calculations of the chain as well. For instance, when you take example of intents, you say, hey, I'm willing to give 1,000 DAI for a certain amount of Ethereum. You don't need to go through an AMM. As long as you can verify you got the desired token and you gave the token that you're willing to give. And if the outcome is satisfied, the calculation can be anything that a solver wants it to be. Same goes for, let's say, roll-ups, where all the state transitions happens at the roll-up and managed by sequencers, and then simply the proof of all the state transition is submitted to L1s. So it sort of like follows the same mechanism where things happens on the chain and they're verifiable on the chain. That's it. So that brings down the cost of state transition and execution really, really low. And it also removes like entry barriers and a lot more things.
And with ZK proofs and like other sort of storage proofs, optimistic proofs, it becomes much easier to build like more complex, more processing heavy applications off chain and then prove them on chain, because I think you sort of realize that doing everything on a global consensus is not efficient. So you can put some things off the chain as long as you can prove them, like Abhimanyu said.
Right. So the idea is that you keep the verification
So
decentralized.
just one more thing. You need to make sure that the incentives are aligned so that these things don't become centralized. So like still like keep that decentralization ethic alive, incentivize everyone properly. Otherwise we'll go back to like the same thing that we had earlier.
Exactly. That is the main fear. Okay. Beautiful. Abhimanyu, Onak, thank you so much for explaining to us this new sort of layer that's making its way into how blockchains work. Intents, they were all the rage before this short bull market that we're having. Now speculation has taken over, but the good tech will overcome the bull market and will be there maybe to enable the last leg of this bull market. So thank you so much, guys, for coming. Thank you for educating us in intents, solvers, Epoch Protocol, and yeah, thank you again.
Thanks for inviting us. Yeah.
And yeah, again, looking forward to see how you guys rock it. Super interesting, by the way, and very well explained. Thank you so much. Take care.
Bye-bye.
Have a good day, all of you.